celestial body, we just mean any object in space. And we can do that if you have another object orbiting it. So for example, we're going to do this example with the Saturn and the Sun. Your assignment has a question where you're finding the mass of a black hole based on orbiting information. It's the exact same process, okay? So we know the orbital period of Saturn around the Sun, and we know the distance from Saturn to the Sun. And even astronomers now can look into space and they can see, distant stars, and they can look at objects orbiting those stars, and they can measure these two items. That's actually not that difficult. So given those two pieces of information, then they can find the mass of some star that's far, far away. But we're going to look at this example specific to the Sun. So the strategy you use, of course, we're talking about circular motion, is that the centripetal force with an orbit is gravity. And so if you just equate those two things and then use the formula for centripetal force, that includes period, because that's what we're given in the question this time. And of course the equation for gravity. And just to be clear, I'm saying little m in this case is the orbiting object, as it always is, okay? And the big M here is the mass we're looking for. This will be the mass of the Sun. So this is mass of the Saturn, product of mass of Saturn, mass of the Sun, and r is the distance from Saturn to the Sun, center to center, okay? T is the orbital period, and all we have to do is rearrange this to get big M by itself, and then we can solve for the mass of the Sun, which of course we could just Google, but anyway. So just looking at that, first thing is those m's cancel because they show up on each side of the equation, and when you get m by itself, this is what it looks like. A couple little things specific to this question is we're given the radius in meters, which is good. If it was in kilometers, you would have to change it into meters. And we're given the orbital period in years. And so looking at some ACFU here, we can change that year into seconds, okay? So 24 hours a day, 3,600 seconds an hour, and 365 days per year. So returning here to the equation, you just take the period. It's going to be some really wild numbers in your calculator, but if you solve it properly, we get 2 times 10 to the 30. Hard to tell if that's a good answer. I know that from just experience, I know the mass of the Sun, but let's Google it and see if that's actually a good answer for the mass of the Sun. And you see it'll just come up here. So it says 1.99 times 10 to the 30th. So obviously, with a little bit of rounding error, we got the right answer. So check mark, that question is done. And now you're all set to do your black hole question on your assignment.